All right, let's jump right into this explainer. Today, we are tackling a truly massive challenge facing modern infrastructure. We're going to break down the process of bringing modern cybersecurity, specifically zero trust principles, into the physical world of operational technology. It's a critical shift, and as we're going to see, it is definitely not a copy and paste job.
We really have to start by asking ourselves this pretty terrifying question. Because, look, we aren't just talking about a stolen password or a temporarily downed website here. When operational technology gets breached, we are talking about disrupted power grids, contaminated water supplies, and direct threats to real-world human safety. The stakes literally could not be higher.
Historically, operational systems were totally air-gapped. I mean, they were completely physically isolated. But today, it's a massive web of connections. IT and OT are deeply intertwined. And while this convergence brings incredible efficiency, it also expands the attack surface dramatically, giving threat actors a digital pathway straight into our physical processes.
Here is our roadmap for this explainer. First, the cyber-physical threat landscape. 2. Why OT is fundamentally different. 3. Govern, bridging the divide. 4. Identify, asset inventory and risk. And finally, protect, network microsegmentation and access. Section 1. The cyber-physical threat landscape and the escalating threat to physical infrastructure.
So threat actors are absolutely exploiting this IT and OT convergence. We're seeing state-sponsored groups like Volt Typhoon sneaking into IT networks just to snatch Active Directory credentials. They use techniques known as living off the land, which basically means they abuse the native, legitimate tools already on your system so they can completely hide their tracks. They use the IT side to pre-position themselves, just waiting for the right moment to pivot into the OT network and cause catastrophic physical disruptions.
And that brings us to the core philosophy of Zero Trust. It demands a huge mindset shift. We just can't rely on a hard outer perimeter to keep the bad guys out anymore. We have to engineer our defenses, assuming the threat is already inside the house. We have to continuously validate every single user, every device, and every connection. Section 2. Why OT is fundamentally different. It's essentially a culture clash between two technological worlds. To really grasp this, we need to clearly define operational technology. OT is all about systems that directly interact with the physical environment. We're talking about sensors, actuators, and logic solvers running continuous physical processes in real time. Think about it like this. If an IT server reboots, someone's spreadsheet saves a few seconds late. But if an OT controller reboots, a manufacturing line halts, or a critical safety valve fails to open. There are 3 massive constraints that make OT so tricky to lock down. First up, availability. OT needs near-constant, uninterrupted uptime. Second, legacy systems. You're dealing with hardware that has decades-long lifespans, running proprietary protocols that might actually crash if you try to hit them with a standard IT vulnerability scan. And third, they operate with extremely limited logging, which makes threat detection incredibly difficult. Section 3. Govern, bridging the divide and establishing cross-functional teams and policies. Bridging this gap requires a completely unified approach. You absolutely need cross-disciplinary teams, where the IT folks truly understand the safety constraints and the OT operators actually understand modern cyber threats. Plus, you can't just rip and replace a power plant's entire control system overnight. You have to use strategic procurement. That means ensuring every new piece of equipment you buy has built-in security features, so you can slowly phase out that insecure legacy tech over time. Section 4. Identify, asset inventory, and risk. This is all about knowing your systems and the physical consequences.
You know the golden rule of cybersecurity, right? You cannot protect what you cannot see. Building out a comprehensive asset inventory is absolutely foundational. But remembering those legacy constraints we talked about, standard active network scanning in OT can literally knock older devices right offline. Because of that, passive monitoring, which is basically just listening to network traffic without actively pinging the devices, is almost always your best and safest bet.
Because any little change can impact physical safety, you absolutely cannot just push a software update on a Friday afternoon. Every single modification has to go through a strict, formalized management of change process. It involves sequential, multidisciplinary checks. You need engineering, safety, operational, and maintenance sign-offs before a single line of code or a network rule gets altered. It's wild how differently risk is viewed in these two worlds. IT threat modeling mainly stresses over data loss and confidentiality. But OT threat modeling, They literally have to calculate the risk of actual physical damage, environmental harm, and threats to human life. In OT, safety is always the ultimate trump card.
Section 5. Protect, Network Microsegmentation and Access, where we build out the technical safeguards.
There are some huge differences in how we handle network segmentation here. The biggest takeaway, OT has an extremely low tolerance for disruption compared to IT. While IT will logically segment things by department just to protect data, OT segments strictly by functional, physical boundaries. This ensures that a compromised system in one area can't cascade and shut down a critical safety process somewhere else.
To actually achieve that robust OT segmentation, defenders lean on a few foundational tools to build autonomous operational zones. One of the most fascinating ones is the data diode. It's literally a piece of hardware that only allows data to flow in one direction. It physically prevents a threat actor from sending malicious commands back into a protected network segment, which drastically limits the blast radius of any compromise.
Then, we take it a step further into microsegmentation, and this is where Zero Trust really shines. We aren't just chopping up networks, we're applying granular rules down to specific assets and users. This means you're strictly separating your standard control systems from your safety mechanisms, and even enforcing read and write permissions on individual data tags within a single controller.
When it comes to identity and access management, or ICAM, segregation is absolutely crucial. You should never ever directly connect your IT directory to your OT directory, because if IT gets compromised, OT immediately falls right with it. At the same time, you have to implement emergency break glass procedures. If there's a physical emergency on the plant floor, an operator cannot be locked out by a glitchy multi-factor authentication app. Like we said, safety always comes first.
Finally, since a lot of these highly sensitive OT systems are still air-gapped from the internet, a massive attack vector is simply removable media, like someone just plugging in a USB drive. To protect against this, organizations have to implement incredibly strict rules. We're talking mandatory data encryption, super tight authorization procedures, and rigorous auditing every single time a piece of physical media crosses that OT boundary.
So, as we've seen, applying Zero Trust to operational technology is a pretty delicate balancing act. You're constantly navigating ancient legacy tech while prioritizing real-world safety over strict data security. But by adapting these Zero Trust principles using structured collaborative frameworks, we can absolutely secure the future of our most vital physical infrastructure against some incredibly sophisticated adversaries.
I'm going to leave you with this final, provocative thought to evaluate your own environment. If an adversary was inside your network right now, today, would your physical operations actually survive? I highly encourage you to use the insights from this explainer as a blueprint for your own Zero Trust journey. Thanks so much for joining me, and stay secure.